All right, y'all. Sorry I can't be there today. We're gonna still take notes, and hopefully you guys are able to grasp this concept called coterminal angles. It's really one of the best concepts, probably, if there was one that I had to pick for me being out, because coterminal angles just means same, and that's basically all you're going to do is find a bunch of angles that are actually just the same angle. We're going to have a lot of vocab, and we will kind of keep reinforcing some of this vocab, but as far as like crazy math, there's really just plus and minus. There's nothing crazy to do. So first, let's just talk about quadrants. This is something you might have heard in physics, and we always start here in the top left. This is quadrant 1, and then we just go counterclockwise. So if that's quadrant 1, this is quadrant 2, quadrant 3, quadrant 4. So there's going to be times where I'm going to ask you, hey, what quadrant is that angle in? And you'll have to know, these by memory. Positive and negative angles. There are two different directions that angles can go. So we always start here. This is this is our 0, right? This is our starting point, and then we have two directions to go. We have the positive and the negative direction. So we can have, for example, something like positive 45 degrees, and then negative 45 would just be going the opposite direction. So instead of starting at 0 and going up 45 degrees, I would go down, and that would be negative 45 degrees. Okay, so negative 45 degrees would be in the clockwise direction. Positive is in the counterclockwise direction. And again, this is some of the stuff you might have seen in physics or something else. But that's a very basic concept that will be very, very important, because direction definitely does matter for the type of angles that we'll be doing. The next thing I want to do is just have you guys label the most important angles, which are the ones that make you differentiate between the quadrants. So like I said, this is 0, right? And then we've got a right angle, so we got 0, then we got 90 degrees, right? Because if I made an angle here, that would be 90 degrees. And then we've got 180, and then we've got another, add 90 to that, so that would be 270. And if we come all the way back, that's one whole rotation, and hopefully you know that one rotation is 360 degrees. Okay, so that is the positive angles, and those are important for you to know, because that way you'll know that if I tell you where is 120, well, you know it's between 90 and 180, therefore it must be in quadrant 2. Okay, or if I tell you where's 300, well, that's between 270 and 360, so it must be in quadrant 4. Same thing for the negative direction. So we can again start off with 0, and then have negative 90, and then negative 180, and negative 270, and negative 360. Okay, now we won't use these as much, but it's just literally the same thing in the opposite direction. Now what we want to do is we want to always find angles from positive 0 to 360. This is what we call our standard position, and that'll be really important. Then I'll kind of show you guys how you make every single angle fit between 0 to 360. Okay, but again, just the most important ones: 90, 180, 270, 360, and therefore you can kind of make your drawing accurate. All right. So the big word of the day, coterminal angles. Well, all that means, coterminal angles are angles which are in the same position. All right, so those are two angles which are in the same position, because there's technically an infinite amount of angles that are in the exact same position. So there's 1,000 different measurements that you can use for an angle. So for example, 70 degrees. 70 degrees is going to be between 0 and 90. So a good drawing would be somewhere over here. So I'm going to call this 70 degrees. All right, that's what this angle is. But there is an infinite amount of angles that are also the same position as 70 degrees. So for example, if you just think of yourself right now, you're looking in whatever direction, whatever's in front of you, you're staring at that. You can look at that same thing. If you do one whole rotation, you end up at the exact same spot, right? So if I went from 70 and I did a whole another rotation, I'm in the same spot, right? But mathematically, what is that? Mathematically, that's 70 plus 360. And so you can also say that this is, let's see, 430, right? So this angle can be called 70 degrees, but it can also be 430, right? It's the same angle, literally the exact same position. Now, to think about it a little bit differently, in the same way that you could do another rotation in the counterclockwise direction, in the positive direction, you could do, instead of going from 70 and going in the positive direction, you can go from 70 and go in the negative direction, right? So you can go from positive 70 and then do a rotation in the other direction. And that would be 70, you're going 360 or one whole rotation in the negative direction. So that's going to be minus 360. And that's going to give us negative negative 210, I think. Maybe, no. Negative. This is where you guys yell out an answer because you have a calculator, but I can do it myself real quick. So 70 minus 360. Negative 290. That's, yeah. Okay, so negative 290. So this can also be called negative 290. And you could keep doing that process over and over and over again, right? You can keep subtracting 360. You could keep adding 360. And you're going to find more and more coterminal angles, which are just angles that are the, that's a sloppy 9. That looks terrible. That might have just made it worse. We're just negative 290. So anyway, you can find an infinite amount of angles that are all the exact same angle, which is very useful. Okay? Sometimes you're going to get a really big angle and you want to check what it really is. Because if I tell you 430, you might not know where that is off the top of your head, right? But if you subtract 360 from it, you'd be like, oh man, that's just 70. That's in quadrant 1. Okay, so this adding and subtracting 360 becomes very useful for us to put angles in what's called standard position. So actually, if you go all the way to the bottom of your notes, standard position, that's just an angle between 0 degrees and 360 degrees. So we always usually would like to take an angle if it's really big, positive, or a negative angle, and put it in the standard position. Because if I tell you a number between 0 to 360, you should be able to, off the top of your head, tell me what quadrant that's in. And that's usually very useful for you to kind of know where it's at. Okay. So a lot of times I'm going to say, give me the standard position angle. And you're just going to have to add or subtract 360 a certain amount of times to get the angle that's between 0 to 360. Okay. The other type of problems you're going to have to do is where you find an angle from a diagram. So you're just looking at the picture. Okay, we've got one whole rotation right there. So let's just kind of trace that. That's one rotation. That's 360, right? Already. this is going to be a really big angle. And then we trace the rest to right about there. So I got one whole rotation in the positive, so positive 360. And then we got plus positive 180. And then that last little piece is that 40 degrees. So plus 40 degrees. Okay, so I can add all those up. And that's going to give me 580. Okay, so this picture represents the angle 580. So I'm looking for, the simple measurements like, 100, 360 and 180, and then I'm just kind of adding and subtracting pieces as appropriate. So I'll make a separate video for your assignment to work out a couple of those problems for you, just so you kind of have reference. But I'll at some point check these notes for you guys, and we'll see you Wednesday. Maybe I'll see you guys around the school. Technically, I think in the library or something all day today. All right, see y'all. Hope you have a good day.